Question D, let's find tan negative 120 degrees. And it has to be the exact way. So remember for tan, it is y over x. And drawing my x and y axis, I'm going to draw the angle. So I'm working my way from the initial position and going clockwise because it's a negative degrees. And this is what the angle would look like. Based on that, I need to draw my related acute angle. Okay, so this is my triangle. So if that's 120, that means this related acute angle has to be 60 degrees. So that means this is 90, this is 30 degrees. And I'm going to look back at my special triangle, which is right here. And I habitually always draw a special triangle on the page at least once. And I just kind of keep practicing it. And it's important that you're able to reproduce it every single time so that through practice you have remembered it and it's memorized really well. And to be honest, sometimes I forget like completing the square and little things like that if I haven't done it in a while, but the special triangle, it's less forgetful for me. Anywho, so we have this triangle, so the corresponding side to 60 degrees is square root of 3. Corresponding angle of 30 degrees is 1. And the corresponding side to 90 degrees is 2. I need to put the negatives right here and right here because of the quadrant it's in, and it's a negative x and a negative y, and this is my radius. Once it is all labeled, I can simply plug in. So I have negative square root of 3 divided by negative 1, and so I get square root of 3. E. So for E, I have secant 225 degrees, and that is the reciprocal of the cos function. So I have cos 225 degrees. And so because cos is x divided by r, you have r divided by x instead. So this is your x and y axis, and you have an angle that is past the 180, and so it's going to be in quadrant 3. So my principal angle is going to be from here to here, and that is 225 degrees. However, I need my related acute angle, and I find that by doing 225 minus 180, which is 45 degrees. So I draw my triangle out, and this is 90 degrees, this is 45 degrees. And I'm going to start drawing it so that it is matched to my special triangle. So the side lengths of it will be 1 and 1 right here, whereas the hypotenuse will be a value of 2. I'm going to identify that this is the x and this is the y, this is the r, but I need to consider the negative. So this is a negative, this is a negative, and the radius is fine. When I plug in, I get square root of 2 divided by x, which is negative 1. So it's negative square root 2. And that is my exact answer. So notice that for some of these cases, like C, D, and E, you would have gotten a bunch of decimals rather than a nice whole number because it was a version of a radical. So for question F, we have cotangent 120 degrees. So cotangent is the reciprocal of tan. And instead of y over x, I have x over y. Drawing my x and y axis, I'm going to draw my principal angle, so it's right here. And this is 120 degrees. I need to look at my related acute angle, so this is going to be 60 degrees. And this is my related acute angle. And so we have 60, 90 degrees, and 30 degrees. And I refer to my special triangle, and I'm looking at this one. So the corresponding side to 60 is square root of 3. Corresponding side to 90 degrees is 2. Corresponding side to 30 degrees is 1. And I need to put the negatives. So this one is the only one where the negative is. This is my x, this is my y, this is my radius. when I plug in, I'm going to get -1 for x and square root of 3 for the y. I need to rationalize this. And I'm going to times the top and bottom by square root of 3. And you get negative square root of 3 divided by 3. And that is your final answer. So when you go on to G, seeing this for the first time, you're probably like, what is this? All of the previous stuff was hopefully okay, manageable. And then you get to this. And then you are probably like, okay, this is probably why I can't do it purely using a calculator, but I need to work it out algebraically, okay? So it looks intimidating at first, and it kind of is, but let's break it down. So sine 270 degrees refers to the fact that I need to do y over radius with respect to this angle 270 degrees. And for cos, I have to do x over r. For my cotangent, instead of y over x, I'm going to do the reciprocal, which is x over y. And then I have secant 150 degrees, which is 1 over cos 150. And so instead of x over r, I'll have r over x. So before I go on, I need to break it down in just like I did above, but I'm just doing it in parts. So this is my rough work. So I start off by drawing my 4xy axes. I mean, I'm going in order like 1, 2, 3, 4. So with this red line, I'm going to try to draw my terminal arm for sine 270, which is right here. Okay, 45-degree angle is right there. 60 degrees is somewhere along there. 150 degrees is about there. So I'm going to try drawing my principal angle. So this is 270 degrees. And maybe I can complete this part. Well, for this part, you'll have a coordinate here. And you'll have a coordinate where the x has to be a 0. And when we treat it like a unit circle, then the y value is 1. And the radius value is equal to 1. So this is x and this is y. I'm going to plug in after. So for my second part with cos 45, so that means that this related acute angle is 45 degrees. Whereas this this terminal arm is 45 degrees. Going to draw my related acute angle, 90 degrees and 45 degrees here. Based on my special triangles, now I kind of have it memorized. This is 1, this is 1, this is square root 2. This is my x, this is my y, and this is my radius, which will help us later when we sub in after. Next, I have cos of 60. So my related acute angle is 60 degrees. My terminal arm was 60. My related acute triangle looks like this. If I have a 60 and 90, the other angle is 30 degrees. And so based on my triangle, I've been writing it this couple times, so it's kind of in my head now. This will be a 2 because the hypotenuse is 2 for a 60, 30, and a 90-degree triangle. This is going to be a 1 because my triangle has been cut in half. And then this will be a square root of 3. And this is my x, my y, and my radius. Last part, secant of 150. So 150 degrees. It'll have a principal angle of 150 degrees. Meanwhile, a related acute angle of 30 degrees. 90 degrees over there. And 60 degrees over here. So hypotenuse of this right angle triangle will have a 2 there, a 1 here, because now I see that it's been inverted and tilted, and so it's been cut in half this way, and so this is going to be square root 3. This is my radius, this is my y, this is my x, but this should be a negative to make everything work. So it takes a lot of practice, but as you work with the special triangles a lot, you'll be able to label it quickly, like so. So let's try to plug everything in. So we did all the rough work, which was the hardest part of this, and then we go through it. So for my first example, my y is -1, my radius is 1, so I have -1/1. Next, I have an x value of 1 and a radius of square root of 2. So 1 over square root 2. Minus my x value is a 1 and my y value is a square root 3. So I have 1 divided by square root 3. And my radius value is 2 and my x value is negative square root 3. So we have 2 divided by negative square root 3. So when we put that all together, remember that when we multiply fractions, how we do it is that we multiply these two parts together by multiplying across. And so my first part, I get -1 times 1 is -1. 1 times square root 2 is square root 2. I see 1 and 2 negative signs, so that means I'm going to have a positive overall. 1 times 2 is 2. Square root 3 times square root 3 is going to be a 9, and then square root that's a 3. At this point, you can do it in a couple ways, but I need to rationalize this at the end anyways. So I'm going to multiply this by square root 2 on the numerator and denominator because that's how I rationalize. So I have negative square root 2 divided by 2 plus 2 plus 3. At this point, I need to combine by recognizing the LCD, and the LCD is 6. And I'm going to make it a 6 by multiplying the top and bottom by 3 and the top and bottom by 2. And so I have -3 square root 2 plus 4 divided by 6. So as you go through these questions, if there are questions that you know how to do by yourself, just feel free to skip through until you get to a question you need more help on, and so go through the videos that way, okay? And so for this question, we have 2 cosecant 90 degrees. Well, that's 1 over sine, and so sine is y over radius, and so it's radius over y. Next, I have my 3 as my coefficient. Tan is y over x. Cos is x over radius. That's all set up. Now I need to do my rough work on this side. So I've drawn my 3 x and y axis. So this is my first terminal arm, 90 degrees. 135 is in quadrant 2. 210 is in quadrant 3. So one at a time, I have a principal angle of 90 degrees. As a coordinate, I can treat this as, well, the x value has to be a 0. My y value has to be a 1. So that is my x, that is my y, where the radius is equal to 1 when we treat it like the unit circle. So when we're dealing with quadrilateral angles, which are the angles that fall on the x or y axis, remember I can treat it as like the unit circle because this is the most simplified version of it. So next on to tan 135 degrees, we have a principal angle of 135 degrees with a related acute angle of 45 degrees. So I'm going to extend this so that I can draw this out. A 45-degree angle suggests I have 90 degrees and 45 degrees as my other angles. And keep in mind, I know that it's 90 because it's on the axis, right? And so it has to be making like this perpendicular angle. So according to the side lengths for the 45 degree special angle triangle, I have sides of 1. With the hypotenuse of 2, where this is my x and this is my y and this is my radius, where this is a negative value. On to the third one, cos 210. So I have cos 210. This is my principal angle, 210 degrees. The related acute angle is 30 degrees. I'm going to extend this a little bit. And so this is 60 degrees as a result, and this is 90 degrees. So the way I look at it, that means, well, my hypotenuse is a 2 every time. I've cut it so that it's cut this way. So then this has to be 1 and this has to be square root of 3. This is my x, this is my y, this is my radius. Are there any negatives? Yes, there are. Negatives all the way. So that is my drawing. Now I have to plug in. So I have 2. Radius of the first one was 1. My y is 1 minus 3. And then y is 1 for the next one. X is negative 1. My x is negative square root 3 divided by radius, which is 2. So I'm going to go ahead and multiply these, and this is how I'm going to do it, right? The numerators, and then with the denominators, that's how I multiply. So 2 times 1 is 2, divided by 1 is 2, so that's just a 2. I have 1, 2, 3 negatives in total, and so overall this is going to be a negative. So multiplying across, I have a 3 times 1, which is a 3, and then square root 3, and then 1 times 2 is 2. At this point, I want to consider what the LCD is. LCD is 2, the lowest common denominator between the two denominators. I'm going to multiply this by 2. And so I have 2 as a denominator, a 4 here because 2 times 2 is 4. And this is my final answer. So it's number 7, without using the calculator, explain how you can find the solution for angles to the following. So whenever that negative sign is like in front of the fraction sign, I usually rewrite it so that I have negative square root 3 divided by 2. My numerator is the x and the 2 is my r. Okay, so let me draw you a visual of why this is so. If I'm looking for my related acute angle, I'm interested in this side, correct? Because they are corresponding to each other. This is the corresponding side to this corresponding angle. And so if you look at this, well, this is the y, right? This is the y, and I'm not worried about the x, not the r, but I'm worried about the y when I'm trying to find my theta r. Based on this information, I'm going to write down the following instruction. So find the side y, since across from it will be theta r, which is what I said in my little drawing that I erased. So y is going to be what? Well, if I'm dealing with a triangle that is dealing with the dimensions of square root 3 and 2, square root 3 and 2, well, I'm dealing with this special triangle. Notice that? So this is my radius, and this is my square root 3. That means my y value is 1. It's just that my triangle is probably tilted to make it work. And so I'm going to write down y is equal to plus minus 1. At this point, I am going to do a very important step. If y is equal to plus or minus 1, I can find the related acute angle accordingly by looking at my triangle. So with my 1, so my corresponding angle to 1 is 30. And so based on this, I'm going to write that my theta r is equal to 30 degrees. Probably one of the most important part of at least this question, this highlight. We're going to do 2. Number 2 is decide which quadrant the angle is in. And this is based on whether the x or the y is positive or negative. So when we think about drawing that out, that means my x value has to be, well, this is my x-axis, this is my y-axis, this is where my x's are negative. Therefore, I'm going to have an angle right here, and that's going to make sense. That's where my y value is positive. Am I missing something? Well, because there's a positive and negative that is possible for my y value, I'm going to also draw another angle, another terminal arm. Figured out step 1 and step 2, and I'm going to draw that this was 30 degrees and this is 30 degrees. And that is enough information. And as an FYI, this is a 1 and this is a 1. a negative 1. And when I'm trying to find my theta 1, which is right here, and my theta 2, which is right there, well, my theta 1 is equal to, well, this is 180, and you take away 30 to get this black arrow, right? And so that is equal to 150 degrees. For the next one, if I have 180, I'm going to add 30 to get my theta 2, and this is equal to 210 degrees. Those are my two angles, and I'm just going to write down the final steps of what we did, which was to find theta 1 and 2. And we did theta 1 by doing, we got the theta 1 by doing 180 minus 30 degrees. And we got theta 2 by doing 180 degrees plus 30 degrees. Okay, for question B, tan theta equals, you have square root of 3 divided by 3. So there's no special triangle where I have the value square root 3 and a value of 3%. But I realize that this is like the rationalized version. So I'm going to divide both the top and numerator by square root 3. And when I do that, I will get 1 over square root 3. So I wrote here that this is like the not rationalized version and this is the rationalized version. And I work with the fact that since there's no special triangle with side of 3, I could kind of tweak it so that I can actually simplify it to become the one of the ratios for the special triangle. According to tan theta, that 1 is y and that is x. However, I will also have negative 1 and negative square root of 3 as my other answer. So for my special triangle that deals with 1 and square root 3, that reminds me of which triangle? The one over here. All right, and so basically my y value was equal to 1, and so that means that the corresponding angle to 1 is 30 degrees. So I'm going to write y is equal to 1, and its corresponding related acute angle is 30 degrees based on my special triangle. I'm going to draw my x and y axis with the appropriate angles. And where am I going to draw it? So let's see. I have a y value of 1. Okay, so in this case, a positive number. That means my y value is over here, right? And then my x value is a square root 3. So that means my x value is actually over here. So that's in this quadrant. So both of these positive, since both values are positive, it suggests that my first terminal arm is in quadrant 1. When I have a negative 1 and a negative square root 3 for my y and x respectively, that means that the values has to be here. And overall, so see how it's like a positive slope that you have. And so my related acute angle is 30 degrees. And based on this, you're going to find your theta. So this is your first terminal arm, so that's 30 degrees. And from here to here, I have a theta 2 of 180 plus 30, which is equal to 210 degrees. So first step of dealing with this question is I want to write that negative and push it, let's say, to the numerator and interpret it. And so this is my y and this is my radius. By the definition of what sine is, I'm going to draw my x and y axis and try to draw my 2 or 1 or whatever number of terminal arms, depending on the situation. Y is equal to negative square root 3. And so that means I am dealing with the triangle with square root 3 and 2, which is the one on the left. And the corresponding angle to square root 3 is 60 degrees. So I'm going to scroll down and say that my related acute angle is 60 degrees. From there, because my y value is negative square root 3, that means that I have two possible terminal arms right here and right there, because that's where my y values are negative. Here are my terminal arms. This is my acute angle of 60 degrees. I'm going to draw my terminal arm so that this is theta 1, and theta 1 is equal to 180 plus 60, which is equal to 240 degrees. My theta 2 is equal to 360 minus 60, which is equal to 320 degrees. And that's it. So question D, tan theta is equal to negative 1, which has a denominator of just 1. Interpreting it, this is my y, this is my x. So basically we are dealing with an x and y axis and where you have a negative slope. And let's go through it the way where we have, well, y is negative 1. And for the value 1, when we scroll up, there are two scenarios. Unlike the other ones, one can have a corresponding angle of 30 degrees. One can also have a corresponding angle of 45 degrees. So I'm going to write both options down for now. So theta r is equal to 30 degrees or theta r is equal to 45 degrees. So the reason I'm going to cross this one out is because I am right now dealing with a triangle where I'm dealing with side lengths 1 and 1. That means when I go back up, I'm not dealing with this one. I'm actually dealing with this one because my two side lengths are 1 and 1. So I've eliminated 30 degrees and I have a related acute angle of 45 degrees due to x, the other side, equaling 1. So at this point, drawing my terminal arms, and it has to be where? Where is my y value negative? So my y value is negative over here, and my x value is positive over here. And so that is one version of the answer. But keep in mind, I could have rewritten this so that I have it as 1 over negative 1, like that. And so because of that, that means I can have a positive 1 and then a negative 1, and it's going to be right here. And so my related acute angle is 45 degrees with respect to the x-axis. And when I draw my terminal arm, this is theta 1. And 180 minus 45 is equal to 135 degrees. Theta 2 is equal to 360 minus 45, which is equal to 315 degrees. Okay, so moving on to question 8 of the third page. Number 8, for the point P, negative 2, negative 8, find the exact values of the three primary trig ratios for the principal angle that is made with the terminal arm with point P on it. So what I'm gonna do right away is when I see that point, I'm gonna want to see a visual of what's going on, and therefore I'm going to find the I'm going to draw what this looks like so you know what quadrant it is and etc. And then you'll realize what part is missing, right? So let's start off with drawing the x and y axis. So with negative 2, negative 8, that means your coordinate is going to be around here. So you have a point of negative 2, negative 8. And so those coordinates are x and y. And this is the principal angle. You start from the initial position to that point. And so that is the principal angle. So you realize you have your x and y, but you're missing the other part. Well, for trig ratios, you have to make sure that when you're finding those trig ratios that you have the y, the r, and the x. And from my drawing, I'm noticing that I have my x and y, but I don't have my r, and therefore I need to find the radius as part of my step. So how do I figure that out? Well, Well, you have x squared plus y squared equals r squared. And I have a x value of -2, a y value of -8, and then r squared. So -2 squared is 4, -8 squared is 64. And so you have 68 equals r squared. I'm going to take the square root of both sides. Because we're dealing a radius, I'm going to grab the +1. So r is equal to square root of +68. So you might be actually tempted to stop here, and like this space makes it seem like we're all like done. But 68, think about that for a second. 68 is divisible by 2. And not only that, it's divisible by 4. And so if I do like a prime factorization on this side based on my previous unit, so 4. So if I put 4 into 68, so 4 goes into 6 once. And that means I have a remainder 2 in my head, so 28. 4 goes into 28 7 times. That's a prime number. I'm going to circle that. 4 breaks into a 2 and a 2. Based on this information, I need to write it so that it's more simplified. And so I have a square root 4 and a square root 17 that is able to be split up by 68. So then r is equal to 2 square root 17. And so now I'm going to move on to the third step. So I'm going to simply plug in from here. So I have a y value of -8, r value of 2 square root 17, x value of -2, radius of 2 square root of 17, y value of -8, x value of -2. So when I work this along, the first part, well, sine theta is equal to y over r, and so -8 divided by 2 is 4, and there's still that negative in front, and so I have -4 over square root 17. So you should be realizing that you have to multiply the top and bottom by square root of 17, and you will get -4 square root 17 divided by 17. On the bottom, cos theta, well, the 2's cancel out, and you get -1 over square root of 17. Multiply the top and bottom by square root of 17, and you get negative square root of 17 divided by 17. And this part right here, they divide and you get a 4. And so you get a +4 as your final answer. And so all of my trig ratios are nicely simplified. Number 9. So the angle theta is in quadrant 3. That's the first information that they give us. And sine theta is equal to -square root 3 divided by 2. Sorry, I dropped my pencil. Point P lies on the terminal arms. Determine theta and state at least 2 possible coordinates for point P. So I'm going to start off by drawing my x and y axis. So they told me that my angle falls on quadrant 3, and that's where quadrant 3 is. Next, I'm going to break this out so that I have sine theta is equal to -square root of 3 divided by 2. And this part is my y, and this is my r. So that was my step 1, and that was my step 2. At this point, I know I'm trying to solve for theta as one of my questions. So let's see, let's break it apart. Well, I know I have my y and I know I have my r, but I don't know my x. So I'm going to go ahead and solve for that. I have x squared plus y squared equals r squared. So x has a value of, well, we don't know that. So y has a value of -square root 3 squared plus, remember the brackets do matter. And then I have equals bracket 2 squared. So x squared plus, well, -square root 3 squared is, well, square root 3 squared is just a 3, and the negatives are canceled out, and so just a 3 is equal to 2 squared, which is 4. I want to subtract 3 on both sides. X squared is equal to 1. I want to get the x by itself. So I'm going to take the square root, and there's a positive and negative answer, and I get the positive. Well, actually, how am I going to decide whether it's a positive or negative? Let's think about that for a second. So this is my coordinate here, right? And this is my x-axis, and this is my y-axis. And if my coordinate is here, my x value has to be a negative. So I have to write and identify that. I'm just going to circle that one. And so I have x is equal to -1, and that's due to coordinate being in quadrant 3. So at this point, my step 3, I want to know what related acute angle I'm dealing with. And so I'm going to say, well, I have -√3, and I want to find out my related acute angle. And I'm going to scroll back to my triangle. So √3 has a corresponding angle with 60 degrees. So I'm going to scroll back down. And so the corresponding angle is 60 degrees for my related acute angle. So I'm going to go back to my drawing board, and based on this information, this is 60 degrees. A very important piece of information, and that way I can draw my rest of my triangle as so. So my y value is -√3. For this type of triangle, my hypotenuse is a 2. Because my triangle has been cut in half this way, the value here is a -1. So this is my x, this is my y, this is my r. So this is my 4th step, which is my point is point, let's say, x comma y. So based on my drawing, my first coordinate that I have is, well, it has an x value of -1 and a y value of -√3. So keep in mind that they are looking for a angle, and the theta, the ratio has to work out so that you're getting this kind of similar triangle. And so if this is a possible coordinate, any coordinate that falls on this line will have the same trigonometric ratio of sine theta equals -√3 divided by 2. So I'm going to draw a black line that extends, and so these are represented by a bunch of P's, because these are any possible coordinate on this extended line. So the easiest thing that I can think of is, if you have this first coordinate, I'm just going to multiply everything by 2. So you can multiply it by any scale factor. You'll have for the second coordinate, if you decide to multiply it by 2, you'll have -1 times 2 is -2. And you'd have -2 square root of 3. That's a possible coordinate. And now I've given you 2 possible coordinates. You could have also times it by 8 instead. And so another example is -8 comma -8 square root 3. But please note that it's a ... which is the math way to say that there's more than one possibility, and there's a whole list of possibilities, but we just had to state 2. Number 10, the terminal arm of theta is in quadrant 3, and on the line, blah, 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 determine the angle theta in standard position. So again, I'm going to quickly draw my x and y axis. Going to draw my terminal arm in quadrant 3. So I have a principal angle where you have a theta there. And we don't know any information other than that. So we're going to move on. That was my step 1. I want to rewrite it so that it looks like it's in the form y equals mx plus b, because they are talking about it as a line. And so essentially I need to get the y by itself algebraically. And keep in mind, by definition, we said that if we're dealing with it as like a unit circle, then the m be represented by slope, which is represented by tan theta, as long as we're dealing with it as like a unit circle. And so let's go through this. Square root of 3y minus 3x equals 0. Get the 3x to the other side. And I have square root 3y is equal to 3x, as this part cancels out. I want to get y by itself, so I'm going to divide both sides by square root 3. So y is equal to 3x divided by square root 3. So I don't ever want to have a radical on the bottom, so I'm going to rationalize by multiplying the top and bottom because it's a monomial, and I can do that like so, and you get 3 square root 3x divided by 3. Well, I have a 3 and a 3 on the top and bottom, so I can cancel those out. Is equal to square root 3x. And so m, the slope, is equal to 3, or I can now explicitly say that tan theta is equal to square root 3, which has a denominator of 1. And when we break that down, we have this as y, the square root 3 as y, and 1 as x. Fourth step, I am going to do what? What do you think? Basically, I have my y and I have my x, right? And I don't really know anything about my related acute angle, which is a piece I need. And remember, when you have the y value, what can you do? Well, y is the corresponding side to my related acute angle, and therefore I can say y is equal to square root 3. And when I look at my right angle triangle, I know that square root 3 has a corresponding angle with 60 degrees. Theta r, the related acute angle, is 60 degrees. So I'm going to go back to my image and say, well, from here to here, that is 60 degrees. And if that is 60 degrees, you can now find your theta, and theta is equal to 60 plus 180, and therefore it's 280. And that is my final answer. And to make it even more explicit, I'm going to rewrite it here, because theta equals 240 degrees is what the question was asking, but I kind of went through it in a funny order, but there was a process to how I got this answer. I started with my drawing, but I needed to do some work to add to it.